This example is gonna encompass how you could use the angle identities in its full form, and also linking all of the things you've learned so far about angles and quadrants and so on. So say you have that cos theta is 1 over 2 and that theta is obtuse. You are required to find sine theta, sine 2 theta, cos 2 theta, and tan 2 theta. And you can actually do it without finding theta itself. I mean, it's easy to find it with 1 over 2. This is part of the exact values, but you don't have to. But one thing to note, the fact that they're saying it's obtuse is quite important. Cos theta being equal to, sorry, this is meant to be negative a half. Give me a signal, because cos theta can't, if theta is obtuse, cos theta can't be positive. So obtuse means that we're dealing in the second quadrant and only sine is positive in that quadrant. So sine is positive, and this will come in handy. So just to fix this, it's meant to be half 1 over 2. So to find sine theta, you can watch a previous video where I show how you could find one of these trig ratios when only one is given. You can find theta if you want to, but you don't have to. What I'm going to use Pythagoras' identity. And in order to find this, I'm just going to go 1 minus and then take this half. And then that's going to give me my my value for sine. So sine is going to be square root of 3 over 2. And it's going to be positive because we're in the second quadrant and sine will be positive. If it wasn't, if it was, say, in the third quadrant, then this has to be negative. But it's positive for now. For sine 2 theta, this is where the identities come in handy. So you have 2 sine theta cos theta is how you'd calculate this. And you'd go, well, 2, I know what sine theta is. Sine theta is precisely root 3 over 2. And I know what cos theta is. That's negative 1 over 2. And if I calculate it, that will be a negative root 3 over 2. Then for cos 2 theta, you can pick any of these. All of them would work because you have all the values. This is a nice thing about the double angle identity for cos. It's just we have so many options. I'll pick the first one, and I have 1 minus 2 sine squared theta. I have my sine theta as root 3 over 2, and I'm squaring that. And then plug it in, and that will be negative 1 over 2, or you can do it on your own. Now, tan 2 theta, you don't have an identity here. There are some different levels in curriculums that would study the double angle identity for tan. So IB, AAHL do have the identity for 2 theta, but it's quite easy to do, especially if you have these already. So this will be sine 2 theta over cos 2 theta, and you have these values already. So you have a negative root 3 over 2 divided by a negative 1 over 2. The negatives will cancel out, the 2 will cancel out, and you're left out with root 3. So hopefully this example is clear. It's just to show you how you can combine all of these processes together. In other videos, I go through actual how you would actually solve equations using these identities.